All right, we've got two really important calculator features today. So you kind of go to the same spot, more or less. It's kind of one feature. They just have a little difference as to when it's appropriate to use. Because they're together in the same spot under second vars, but you just have to choose which of the two that you want. Okay, you can tell by the title of the tutorial. It's Binomial Pdf and Binomial Cdf. Okay, you'll find both of them under second vars, which should look a little bit familiar that we've used normal CDF. Okay, the normal function for the PDF we don't use. Okay, so our only experience here, well, we've used inverse norm too. Okay, so these features do calculators about distributions. The only thing is, in chapter 6, we have now been introduced to a distribution called a binomial. Okay, so if you identify that a distribution is a binomial, and you want to calculate the exact number of successes. Okay, so I'm going to go off of our notes and use that example about the are you guessing game or little deal on the quiz, right? The 10-question quiz to kind of predict or put probabilities with scores if you're just guessing on every question. Okay, if you remember from that problem, it had 10 questions, okay, which we would say for a binomial is what we call n. That's the number of trials. The next thing you enter, and keep in mind your calculator probably gives you prompts to put these things in, is the probability of success. For a binomial, that can't change. Okay, it has to stay fixed. That's the value that we call p. Okay, remember, if you're using this feature for like a written homework or a test question, you have to state that your distribution follows a binomial, and you have to quote n and p. Those three things you have to state in writing, then you're good to just get some answers from the calculator. The last thing you put in is the prompt. We'll call it an x value. We would say in binomial terms, it's the number of successes. Okay? And I'm going to say it's 3. But now keep in mind, if I say 3, under the PDF feature, that means exactly 3. It doesn't mean 3 or less. There's the probability that you would guess exactly 3 questions right. A fairly common outcome for this particular quiz, okay, if you're guessing. All right? That's the binomial PDF. Think of probability that x equals 3. Okay? X equals 3. Now let's go back. Just underneath it, we have binomial CDF. Now I'm going to start with the one that we just did to show you that this gives you a different probability. N and P are the same. We have 10 questions on the quiz. There's 5 choices, so the probability we guess it right is 0.2. If I say 3, I'm not going to get 0.2 because this CDF takes every outcome equal to what you stated or lower and adds them together. So this is going to have 4 binomial calculations added together. The probability that you get 3 guesses correct, or 3 problems correct, 2 correct, 1 correct, or 0. Think of those as 4 different cases. Okay? This gives you all of them added together, which tells you that if you're guessing on this quiz, the odds that you were to guess 3 questions or fewer correctly is quite high. Okay? It's actually quite high. Almost 88%. Okay? A huge element to the binomial CDF feature is it only does less than calculations. Okay? So let's say you have to get 6 questions right to pass. Okay, let's say that's the case. And we want to calculate the probability that you'll pass the quiz by guessing. Okay, that is a calculation for the binomial CDF feature. That's what you should use. Okay, and you got to be really careful here. What I'm really looking for is the probability that X, the number of correct guesses, is, let's say the cutoff is 60%, is 6 or greater. Okay, that it's 6 or greater. Directly, the binomial CDF can't calculate that. Okay, because it can only do equal to and less than. Okay, so this is where it gets a little bit tricky. If I were to do this, I would want to say 5. All right. I'm going to calculate the probability that I get 5 correct guesses or less. Okay. There it is. Now, that's not my answer. Okay. I just had to get the closest thing that the binomial CDF feature can calculate. Okay. Because it can do 5 or less. 6 or more is the exact opposite. Okay. In probability terms, we like to call that the complement. Okay, I like using this example because you're able to talk about the complement in really plain terms. We were trying to calculate the probability that by guessing that you could pass, or that you would pass. What I just got there is the probability that you'd fail. Again, if you're guessing. Okay. Well, that's fine if I had to do it that way. Just subtract my answer from 1. There's the probability that I would pass off of guessing. Okay. The way to remember that is if you ever are doing a calculation that is greater than, like this number of successes or more, you have to switch it to a complement before you go to the binomial CDF because it can only do less than. It's not like the math behind switching, it's not crazy. You just switch it to the complement and you do a binomial CDF, then you just have to remember for the very last step to subtract your answer from 1.